This is Cameron Chai bringing another episode of AZO TV, and today we're speaking to Dave Shepard from Netzsch, and he's going to tell us about their new TG209 F1 Libra TGA instrument.
Thank you, Cam. Yes, this is our new version of the TG209 F1, the Libra. It has several new features over our former version of the instrument, which I'll talk about in a minute. A TGA means thermogravimetric analyzer. And what that means is we're measuring the mass change of a sample as a function of time or temperature. So in this instrument, we have a balance in the chassis that it rides below a furnace, and then we have a sample carrier that extends up into the furnace. We put our sample on that sample carrier, and then we normally heat the sample and we measure the mass loss steps that occur as we heat the sample. Okay, loading the sample is very easy in a top loading design. As you can see here, all I need to do is open the top, and the sample carrier now comes up to the top of the furnace. I can then load the sample very easily, and just by 2 buttons, close the furnace. So there's no fragile hang-down wire, there's no horizontal beam that can break, and when you're loading the sample carrier is actually disconnected from the balance, so you cannot damage the balance while you're loading the sample. Okay. Once this is closed, it's now vacuum tight. So that means if we have an oxygen sensitive material, we could pull vacuum and backfill with inert gas so that you don't get unwanted oxidation during the experiment. We could also run an experiment under vacuum or reduce pressure if we wanted to, say, for example, separate a high boiling plasticizer from thermal decomposition in a polymer. By reducing the pressure, we lower the boiling point of the plasticizer, so it will be separated better from the degradation of the polymer.
And Dave, you said the new model here has some new features compared to the previous model. Can you tell us about those?
Certainly. The furnace is a new ceramic furnace that has the advantage that it can go to 1100 degrees Celsius, which is higher than the normal 1000 degrees C furnace that most TGAs can go to. The ceramic furnace also heats faster, up to 200 K per minute, and it's more corrosion resistance. So in TGA, you're going to be reducing a lot of reaction byproducts that come off the sample, and ceramic furnace will be much more corrosion resistant to any corrosive gases that you might be formed. Another advantage of the system, or another new feature, is we do not need to do a baseline correction. In a normal TGA, there's always some buoyancy effect that you have to do a correction run and then subtract out. In our new TGA, we've totally modeled the baseline behavior under different temperature ramps, different purge gases, so you don't have to do a baseline run, and that saves a lot of time in your analysis, because if you want to change conditions, you can just start your experiment right away and not have to do a baseline run beforehand. In addition, there's other features of the instrument that we've had for a while and are also still included. One of which is what we call CDTA capability. And with CDTA, what we have is our sample thermocouple actually touches the sample crucible. So we can detect if there's any if your sample absorbs energy or gives off energy during the experiment. So that gives a qualitative DSC type measurement. So you can tell whether your sample is going through some enthalpy change, maybe a melting. But you can also use that to calibrate the temperature of the TGA, because we can use metal melting standards and calibrate the system exactly like you would on a DSC, just using metal melting standards and creating a calibration table.
Okay, and the design of the furnace there, the way the interlock works, is that the same as before?
The furnace design is the same as before, where it locks and becomes vacuum tight. Yes.
Okay, because it just looks like the design is quite robust, where you don't have delicate hang downs and things like that that are, you know, the sort of things you could break by accident when loading samples and things like that?
Exactly. It's just like loading a DSC. You're just putting a sample crucible on the platform, so you don't have to worry about damaging it. If for some reason the sample carrier would be damaged, you can just replace it yourself. You just pull it out, and it has a quick disconnect, and you can just put another one right in. So you would have essentially zero downtime if in fact something would happen to the sample carrier.
All right then, Dave, thanks very much for taking a few minutes to tell us about the new TG209 F1 Libra TGA instrument. If anyone wants more information about that, they can find that on your website.
At www.netzsch.com.
All right, Dave, thanks for taking a few minutes to tell us about the new TGA.
Thank you, Cam.